Our topic for right now is to simplify an expression. Again, not an equation to solve. We are just simplifying in a sense, sentence fragment. Now what we want to handle here is a lot of phrases that you usually see in learning algebra. Combine like terms is a big thing. And the idea of a term is the fact of what the last name is, the variable part. To be a like term, it has to have the same variable, and if there's exponents, has to also be to the same power. Here's an example. 3x plus 2x minus y plus 4y minus 2w. Whew. Big long list of terms there. If you're trying to combine them and simplify, you can really combine just the first two, 3x and 2x. That gives you 5x. Remember, if you're adding apples with apples, they stay apples. They don't change to bananas or something of that nature. So x's plus x's stay x's. If you have y's, this is negative 1y and 4y, you just combine those coefficients, those numbers, just like you always did. Negative 1 and a 4. Again, remember, a y with a y is going to stay a y. Dollars with dollars stay dollars. They don't change into pesos, all right? So you're going to keep that last name, the variable part, the same. And again, the 2w here, or the negative 2w, nobody to hook up with, and it's just going to carry on down. That is the last step there. Don't try to shove it anymore. The fact that those are three different variables, we're done. The fact that there's nothing else that is alike. Remember, two quick little things. An x plus an x will give you 2x. Those coefficients are sort of those invisible, you can't quite see them, ones. And so a 1 and a 1 make 2. Also, if you have 2x plus 2y, you're done. The fact of the x's and y's, nothing in common. They'd have to both be x's or both be y's. All right? Keep that in mind. Before we get into anything further, let's just sort of talk about some little vocab words. Very important, though, the fact of what we have here, the commutative property. The fact that you can multiply numbers in any order or add in any order. Some people call this like a turnaround fact, because you can do it in either way. 3 plus 2, 2 plus 3. Get the same answer. Associative. This really means that you don't really care who you associate with, or you're grouped together, if it's adding or dealing with multiplication. All right, notice again, just those two operations. Distributive, it gets my 3-star rating. That one we're going to use and abuse and beat that into the ground throughout the rest of our math career, because the fact of if you have, in this case, A times the quantity, B plus C, you could, if you were able to, do what's inside first and then multiply by the number outside. Or you would get the same thing as if you took A times B and then A times C and added together. Now let's put in just some generic numbers here. 3, 2, and 5. It would be great, hey, 5 plus 2, know that one, and you get a 7. And multiply it by 3, and you know you're going to get 21. Notice how you get the same thing as if you took 3 times 2, which would be 6, 3 times 5, which would be 15. Hey, 6 plus 15, give me 21. Now usually after seeing an example like that, students are like, well, what's the big deal? I think it's easier just to do this. I'm going to always just add what's inside first, because order of operations, I'm going to do what's in parentheses first, and then multiply after. There's one little sort of problem with that plan, and let me show you. What if, instead of the 3 and the 2 and the 5, smack, you don't have the 2. You don't know what the 2 is. The 2 keeps changing. It's a variable. Now you are like, well, let's see here. I'm doing the best I can do. Since I can't, there's nothing to do. Those are two different terms. Can't do anything there. The best you can do is to remove that grouping symbol. You would multiply 3 times x, which is 3x, and 3 times 5, which would be 15. Some people don't think that that's quite simplified, but yeah, it sort of is. The fact of you really now don't have those parentheses, a grouping symbol, and you actually have just two terms here, the 3x and the 15. There's a little bit more sometimes that you have to watch out for. And that is if you're dealing with a negative. If you have a negative in front. Again, you could have a positive number, a negative number, fraction, a decimal, anything, and even later on we're going to see how you can have a variable term in front of there. But distribute, 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 multiply, multiplying, that is the main basic thing you want to always keep in your head. -4 times the first term, got it. Again, remember the coefficients, all that positive negative rules still apply. So you'd have -8x. -4 times -5 is a positive 20. You don't necessarily maybe need to write it out once you get in a good comfort zone. -4 times -5, you can almost get good, okay, I'm going to do that in my head, negative times negative is positive. But in the beginning, when in doubt, you can write that out. Now that would be our final answer in that particular problem. But look at this next little example. We have 2 times a quantity and then 4 times a quantity, all joined together. So it's really sort of 2 problems in one. We're going to go through and distribute the 2. So we'd have 2x plus 6y. We're going to distribute the 4. So 4 times 4 is 16x. And 4 times -2y is the -8y. You don't want to just stop there, because you can go through and add some like terms. 2x and 16x is 18x, and then we're going to go and have 6y and -8y. Don't worry about those negatives, even if they're fractions or decimals. Just pay attention to detail, and hey, I would have a -2, and again, that would be -2y. Can't go any further. X's are X's, Y's are Y's. 2 totally different terms. And as you can see, the main thing here is to practice, to get very comfortable with your decimals, with your fractions, with your positive negatives. Really just bringing all that stuff that you already have in your head, but just sort of bringing it together, all right? But you can do it, you just have to practice.